tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse 1 by 2. So here left hand side we will take left hand side is equal to tan inverse 2 by 11 plus tan inverse 7 by 24, and now use the formula. So what is the formula for tan inverse x and plus tan inverse y? Tan inverse x plus tan inverse y. This is frequently used in our previously questions. Tan inverse a plus b. This is coming tan a plus tan b, 1 minus tan a tan b. So this will be tan a plus b, plus will come up because in a plus b, tan a plus tan b, 1 minus tan a tan b. From that you can remember. This formula is applied here. So it will convert into 1 tan inverse. So therefore we can write tan inverse 2 by 11. Here x is 2 by 11 plus 7 by 24 divided by 1 minus 2 by 11 into 7 by 24. Okay. Now tan inverse we will solve it. So 24 into 11, just you can take the LCM. 24 into 11 is equal to 264. 264. This is the LCM of the numerator. 24 multiply with 2, 48. Here 7 will multiply with 11, 77. Similarly, in the denominator also, 24 into 11, again 264 is the LCM here. The 264 into 1, 264 minus 7 to the 14. Okay. And here this 264 will cancel with 264. And this will become tan inverse 48 plus 77, 125 divided by 250, divided by 250, 125 to the 250. That's all we got. Tan inverse 1 by 2, that is equal to right hand side. So very simple questions are there in previously. So just you have to remember the formulas. Next question, question number 4, same exercise 2.2, question number 4. Prove that 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse 31 by 17. You have to bring 31 by 17. So before this 2 getting inside the inverse of tan, we cannot put tan inverse x plus tan inverse y. Okay. So that's why we have the formula 2 tan inverse x. First we will use this formula 2 tan inverse x. Here I am showing what formulas we are using in that particular question. So 2 tan inverse x from tan to theta, it is 2 tan theta upon 1 minus tan square theta. So 2x upon 1 minus x square. This is the formula of 2 tan inverse x. So first use this formula. Okay. So we are taking left hand side and putting this formula here in this part. So 2, this will become tan inverse. What is x here? X is 1 by 2. So this will become 2x, 2 into x, and x is 1 by 2 divided by 1 minus x square, that is 1 by 2 whole square plus tan inverse 1 by 7. Solve this one. This 2 and this 2 will cancel. We get tan inverse. Numerator it will become 1, and denominator you have to solve 1 minus 1 by 2 square means 1 by 4. Okay, and plus tan inverse 1 by 7 as it is. Now this 4 you can take the LCM in the denominator. 4 will be the LCM, and 4 ones are 4 minus 1, and this is numerator. Huh? We are solving the denominator, so this will become plus tan inverse 1 by 7 as it is tan inverse 3 by 4, and this will come up, so it will become 4 by 3. This is 3 by 4 because of this one. This will become reciprocal of this will become 4 by 3 plus tan inverse 1 by 7. Okay, now we can use the formula. Now here we will use the formula tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. So we get tan inverse x plus y means 4 by 3 plus 1 by 7 divided by 1 minus 4 by 3 into 1 by 7 to 1 by 7. This is 7. Okay. This will become, now I'll write here, tan inverse 3 by 4 by 3, the LCM of 4 by 3, 1 by 7 is 7 3s are 21, and 7 we multiply with 4, 7 4s are 28, and 3 ones are 3. Similarly here 3 sevens are 21. LCM will be 21 minus 4. So this 21, these steps are same, generally is cancelling always, and we get tan inverse 28 plus 3 31, and 21 minus 4 is equal to 17. You can see that we have to bring 31 upon 17, that is equal to right hand side. So you just have to remember the formulas and just put in the question. You can get easily. So sometimes we have now simplest form. Now the next type of question, that is question number 5 or exercise same, exercise 2.2, question number 5. Now we have to write in the simplest form. Question is now write, before that we proved, now write in the simplest form. Write in the simplest form. Question is tan inverse under root 1 plus x square minus 1 divided by x. This should be converted into the simplest form. So we have to put the value of x here. Generally, we are trying to get inside here. We will try to get 10, so that 10 inverse 10 will cancel and we get the answer in theta. So we will have to 90% in questions we are putting x is equal to 10 theta, because 1 plus 10 square theta is equal to sec square theta. So this will convert into sec and this will be tan theta. When we will solve it, we can easily get tan theta. How? Just see that. And then we can see that x is equal to tan theta, so theta will be equal to 10 inverse x. Okay, so now we will substitute in this one. Tan inverse, this is, we have to simplify this one. 1 plus x square minus 1 divided by x. So substituting x as tan theta, so tan inverse under root 1 plus tan square theta root minus 1 divided by tan theta. And 1 plus tan square. Now you should remember all the formulas which we did in previous classes. 1 plus identity 1 plus tan square theta is equal to sec square theta. Here I am writing whatever formulas we are using. So this will become tan inverse under the root sec square theta minus 1 divided by tan theta. And this under root and square will cancel. So next step will be tan inverse sec theta minus 1 upon tan theta. Okay. Now it is easy to convert into sine and cos. Okay. So we can write, convert all into sine cos, and then we can convert into tan theta. Because inside this should be tan theta always. Otherwise, this tan inverse will not cancel. Hmm? And we cannot compare with this theta. So what we will write here, sec theta is equal to what? 1 by cos theta minus 1, and tan theta is equal to sine theta upon cos theta. Then again taking LCM in the numerator, so numerator will become 1 minus cos theta divided by cos theta, and denominator is as it is sin theta upon cos theta, sin theta upon cos theta. Similarly, both are divided by same cos theta, so cos theta will cancel. We get tan inverse 1 minus cos theta upon sine theta. And 1 minus cos theta. Now next formula that we will use, 1 minus cos theta is equal to, if you remember, it is 2 sine square theta by 2. This is coming from sine cos 2 theta. Actually, we did by 1 minus, if it is 1 minus cos 2 theta, it is equal to 2 sine square theta. But here, this formula is converting into half angle. So here theta, therefore it will become theta by 2. So this 1 minus cos 2 theta can be written as 2 sine square theta by 2. Theta by 2. Similarly, this denominator sine theta will be converted by this formula. Sine 2 theta is equal to, you know that sine 2 theta is equal to 2 sine theta cos theta. And if this is 2 theta, it will become theta. If it is theta, it will become theta by 2. So from this formula, you can say that if it is sine theta, it can be written as 2 sine theta by 2 cos theta by 2. Half angle sine theta by 2 cos theta by 2. So here we can write sine 2 theta as 2 sine theta by 2 into cos theta by 2. Okay. So now this 2 and 2 will cancel, and sine square theta by 2 will cancel with 1 sine square theta by 2. So we get sine tan inverse. Numerator is sine theta by 2 only. Sine theta by 2, and denominator is cos theta by 2. Okay, got it? So sine upon cos is what? Tan. So we get tan inverse. Inside we got tan theta by 2. So always you have to bring tan theta by 2. For that we have to think which formula should be applied. But this one is complicated one. Theta by 2, we get theta by 2, and what is the value of theta? Theta is tan. So 1 by 2 into tan inverse x. So we got the value of tan inverse under root this. We have started and we reached to the result 1 by 2 tan inverse x. So therefore our answer is, it is converted into the simplest form, tan inverse under root 1 plus x square minus 1 by x is equal to 1 by 2 tan inverse x. Now question number 6, same exercise 2.2. You see question number 6, that is also converted, that is to be converted into simplest form, but we have given tan inverse 1 upon under root x square minus 1. Mod x is greater than equal to 1. This is the condition for the existence of this function. So what to substitute here? Actually, here we have sec square theta minus 1 is equal to tan square theta. So we should put inside the root value of x so that this root should be cancelled. So we will put here, put x is equal to, so whenever it is x square minus 1, you can remember, you can put sec theta, or sometimes if it is in the cosec theta outside is cot theta. So cos sec theta. So sec theta and cos sec theta. So there is a list how to put, where to put what. If 1 minus x square, because 1 minus sin square theta is cos square theta, 1 plus 1 minus cos square theta is equal to sin square theta. So generally here we are putting cos theta and sin theta, cos theta or sin theta. But when it is plus, because x square plus 1 tan square plus theta is equal to sec square theta. So here we are putting x is equal to tan theta. From this you can remember it. So now take to put x is equal to sec theta. That means theta will be equal to sec plus x. Okay, now substitute the values. So tan inverse 1 by under root x square minus 1 can be written as tan inverse 1 by under the root sec square theta minus 1, and sec square theta minus 1 is tan square theta. So you can write now tan inverse 1 by under root tan square theta, and we get 1 by tan theta. Sorry, 1 by tan theta, square and square root will cancel. And if we are getting cot theta this side also, we can convert by 90 minus theta, tan 90 minus theta, cot theta. So that's why if we are getting cot also, so we can easily convert by that formula. So okay, if we are getting cot theta, and cot theta can be written as tan theta by that formula, tan 90 minus theta. Tan 90 minus theta is equal to cot theta. So cot theta can be written as tan 90 minus theta, so it will convert into tan theta. So when there is no square, then we will use 90 minus theta. When there is a square, we have to use the identities. So tan pi by 2 90 degree minus theta, and tan will cancel. We get pi by 2 minus theta, and what is the value of theta? Theta is sec inverse x, to pi by 2 minus sec inverse x. It is converted into the simplest form. Okay. Yes. So therefore, this is tan inverse 1 by under root x square minus 1 can be written as pi by 2 minus sec inverse x. Next question, 2.2 exercise. Question number 7. Again, we have to convert into the simplest form. Tan inverse under the root 1 minus cos x upon 1 plus cos x. Now see, the previous question, there was x inside the inverse. You see this question, inside there is no cos or tan, there is no trigonometrical ratio inside that, but now we have a trigonometrical ratio inside this one. So we cannot put anything, we have to just directly apply the formula, correct? We can apply direct formula for this question, 1 minus cos x, and so you should remember this 1 minus cos x, as I told you, 1 minus cos x is equal to 2 sin square. This is also coming from 1 minus cos 2 theta x by 2. This is the same formula that 1 minus cos 2 theta you have done in this format, 2 sin square theta, but here 2 sin square theta, this is converting into half angle, so x is converted into x by 2. Similarly, 1 plus cos 2 theta Remember that in minus sine will come, in plus cos will come. 2 cos square theta. Or I told you in 11th class how to remember from this. So similarly here 1 minus 1 plus cos theta, denominator is 1 plus cos x. 1 plus cos x can be written as 2 cos square x by 2. So just use the formulas directly. Tan inverse. Just we have to find that the root should be cancelled. We should get the value which should be the whole square, which should have the square on the trigonometrical ratio. To go for further simplification, 2 cos square x by 2. Now you can put the root on the values. So we get under root 2 into sine x by 2. Sine x by 2 divided by under root 2 cos x by 2. So this root 2 will cancel, write tan inverse, and we get tan inverse sine upon cos is equal to tan x by 2. And tan inverse and tan will cancel, we get x by 2. So it is converted into the simplest form x by 2. So whenever any trigonometrical ratio is inside, we can use direct formula. Like in the next question also, we have to use the direct formula. Okay, so you can try rest of the questions.